Hey there, math fans. I'm going to finish this practice sheet on solving. These questions, I threw in 3 at the end that were a challenge problem. I don't know if spending a lot of time on challenge problems related to algebra is good or bad. Mostly we need to know our inverses and the basic solving idea. So if you're fuzzy on that at all, we got to go back and learn that first. Watch my previous videos. The things now here are just more, how do we reach a little farther? Because a lot of equations we can't solve and get an exact answer, so we have to use some approximation method, and you really need some calculus for that. So there's plenty of interesting things to do there. But if we can solve it, if I'm telling you we can solve it, there's some way to disconnect these x's to get them so they can come together. It's more like the variable is trapped, and because it's trapped, it's hard to get it by itself. So anybody that says, hey, solve this, is telling you that there's some way to do it. So in that sense, my goal becomes really clear, is I try to get rid of whatever the offending problem is, whether it's a square root or something else, and then see if I can get to a place where I can combine the x's. So anyways, I think what I would do, even though I know there's more than one way to do this, is I would isolate one of the square roots and say I want to get rid of one of the square roots. So these are harder because you have to be a little more inventive in what you're going to try. I think you could also square it from the get-go. But I know for certain that's going to get rid of that one. The downside is I'm going to need to monkey face out the other side. I need to do this times this, eyebrows, nose, and this is when things just get a little harder. Not everything is nice and easy to solve. The moment you square, you actually introduce possibly more solutions. That's a side comment. I like to always use an example like this. If I told you a was 3, and then you square both sides, and then you solve, you get a is minus 3. And you get a is 3, which doesn't work in the first one. So that sort of illustrates the fact that when you square, you might be introducing more solutions. So that's why I make a note in my head that, the moment I did this, I may need to go check at the end. Okay, anyways, this is going to be 25. There's going to be x. That's the eyebrows. And now let's do the nose and the mouth, but those are always the same. So it's 2 copies of the same thing. And you have to realize that what we just did was progress. I got rid of one of my square roots. Now I'm going to move everything to the other side and isolate this square root. Maybe I'll move it this way. 10 square root of x equals, I'm going to subtract, so that's going to make it minus x. And add the 1, it's going to be 26. I don't know why I moved it to the other side. Now I'm going to square both sides. And again, this is not really getting us necessarily closer to the answer. It's just dealing with the problem at hand, which is trying to get rid of the square roots. This is going to be 100, x equals, and then we get to monkey face again. I think at this point, let's see if we can do it a little faster. Twice the middle is 52x, and then 26 squared. So 26 squared. Enter. There. So for me, that was the challenge. At that point, I kind of go, okay, I've done it. So that's why the main reason I wanted to have a challenge problem is if you don't know the previous stuff we did in the other videos, then you won't know when you've reached something. And then in which case it becomes a really challenge problem. Because we need to be able to get to a point where we can be like, oh, that's something I can solve in the standard way. Move everything to one side. And then we're off to the races. So let's do it. X equals 152. And if you've been following along, how I do the quadratic formula when I have messy numbers is I do the stuff under the radical first in my calculator. So I'm going to do b squared, which is 152 squared, minus 4ac, so 4 times 676. Enter. And that's the number I write here. This is only something I've been doing for a couple years, even though I've been teaching for 20. I've seen so many students in recent years make mistakes with their quadratic formula that I'm suggesting they just compute that right away. It's just less to type in. So then I'm going to hit, and honestly, I probably would immediately hit the square root button too. This is when I have a big number. So at that point then, if I had to get a decimal, if this is not sufficient of an answer, I probably would do the following. 142, so maybe at this point this would make sense. 0.82856686, and then I would then go 152 minus that answer divided by 2. So one of my answers would be 4.585715715715. The other answer would be, so I'm going to do, see, that's where I should have stored the answer. So that was that number. And I need to do 152 plus that. Divided by 2. Done. And I'm getting 147.4142843. This is where I would check. So this is not a great problem. I mostly wanted a problem like this so that you could see, like, okay, that was the extra lift we had to do. Now I would go back and do some checking. It's actually really important I do the checking here. So I would do the square root of that plus this. So this is not pretty. I'm going to take this answer. Let's take the 147, for example. The square root of that answer plus the square root. Uh-oh. No. So this illustrates why you shouldn't do it sequentially like I just did. Maybe this is a time now I can illustrate the memory function. Let's do it. Minus the square root of 20400. Enter. Divided by 2. That's that answer. So you can do store, and you can pick a letter. Let's store it as C. Then from here on out, that's C. So if I wanted to check that answer, that 4.5, I could say, I want to do the square root, and then you can say second recall C. You can see it there. Nice, and it pops it all out. And then you say plus the square root of 2 times second recall C. And then minus 1, go. 5. That one worked. So then if you wanted the other one, so that was with the plus. This is really tantalizing video. No one is watching this. But I hate leaving this off and people saying, oh, he didn't show that step. So let's store this as B, stored. And then let's do the square root of B. I want to see that I'm not afraid to check answers. If this was a really important question to me, this little bit of checking would not be a big deal. But this is, again, this was one of the challenge problems, so it's a little harder to check. Ooh, that one didn't work. That's not a solution. So there you go. Do let me know. I would even want to do more checking if this problem was really important to me. But the reason that's happening is because of this squaring we did, which introduced an additional solution. That's why I was already thinking that maybe one of them wasn't going to work. Okay, that's specific to a very certain thing. All right, let's look at the next one. So once again, we've got the problem where there's kind of these trapped. The point of this problem is, hey, that we had a rule. So the thinking here would be, I don't know what to do, so I'm going to look up my rules. Oh yeah, we had this rule that this is the log of a times b. And so this is the same as the log of x plus 2 times x plus 3 equals the log of 20. Then you can do e. You can exponentiate both sides, and you actually have this. So this was just a problem that looked bad because hiding in there was this problem. At this point, you can expand this out. Let's see, 2 and 3 is 5, plus 6 is 20. And you get x squared plus 5x minus 14 is 0. Two numbers that multiply together to give 14 and add together to give 5 or subtract. So this has me thinking that there's a nice answer here. But that's because I was just thinking about, well, the only ways I can get 14 are 2 and 7. And 2 and 7 could probably make a 5. So that's how I figured that out. That gives 2 answers. So that's a different discussion, the solving there. But the reason I wanted to have some of these questions was so you could see this idea of the moment I got to the quadratic, I knew I had a way to solve it. Now, an interesting thing here is because there was other stuff happening back here, the checking might lead to situations where something's not in the domain. So there's an added benefit to checking. So if I plug in a 2, it actually works, because you're going to get log of 4 plus the log of 5, which is the log of 20 when you put them together. When you put negative 7 in, you get an error. These both give you an error. So this is the other benefit of solving and checking your answer against the original problem, is because then you can see if you get a domain error. That one doesn't work. Again, that was a challenge problem, but it illustrates this idea that if you know how to do inverses and you always check your answers, then you'll be doing pretty good. All right. Last one, and it printed funny. I realize I need to fix that multiplication symbol. That does mean multiplication. Okay. This one to me is a real challenge. I gave this hint that there's a quadratic hiding in there. So the hint is that you had to see that this was a quadratic. You say, I still don't see it, which makes sense. But it's 3 to the t. The fact that you could do this, if it hadn't been for that, then we wouldn't have been able to solve this. But we can solve this because it's a quadratic. You might say, well, how do we quadratic? It's 3 to the t. Well, the trick is to just pretend that's your variable and solve that equation first. Let's call it x. And then once we know what x is, we can say, I need 3 to the t to be x. So it's really two different problems in one. So I was trying to throw at you there aren't that many, weird solving scenarios, but I wanted to show you some of the situations we can handle which go a little bit beyond what we've done because of this. Now, this case I think I can factor. So I get two solutions. Either x is 1 or x is 9. And you can check those here. 1 should work. It does, because I get 1 minus 10 plus 9. 9 should work, because I get 81 minus 90. Yeah, they both work. So then I have two possibilities. I can get 3 to the t could be 1, or I could get 3 to the t could be 9, and this gives me t is 0, and this gives me t is 2, and those are my two answers. So there you go. That's more of a challenge, but it illustrates the idea of so if you're thinking about, there's these challenging algebra problems. They're challenging usually because you have to see something to get it in the form where you can use your inverses or your quadratic formula. So it becomes a game of simplify and hope. Hope that it becomes one of the things we know. So I think that reinforces the idea that really all you need to know is your inverse pairs. Everything else is about simplifying and then realizing I'm there. I can use my inverse pairs, or I can use my quadratic form. I hope that's giving some depth. Let me know if it's helping.